Okay, in this video we're going to look at a model for a conical pendulum. Okay, so it's like a pendulum and you hold it and it goes round in a circle. So what we've got here is if we just start it, you'll see what happens is that the thing will go round and round like that, okay, in the time interval. Okay, so we have let's just reset that for a moment. Okay, so what we have here is a natural length. We have a tension acting here up on the string. We have an angle alpha here. Okay, the radius of the circle that curves out will be that. We've got mg acting downwards, and we've got angular acceleration. The acceleration will be r times the angular speed squared. Okay, so if we click to reveal the model, okay, the vertical component, there's no acceleration. That will just be t cos of alpha, because don't forget, if that's alpha, then if you draw a line up here, this angle here will be alpha, minus mg, that will be equal to 0. The horizontal component, using Newton's second law, okay, that will be, so the same up here, it'll be like t sine alpha is equal to m times the acceleration, but the acceleration is r times the angular speed squared, so we get that. In triangle AOP, r will be equal to sine of alpha over L, i.e. sine of alpha will be r over L. If you rearrange it, you get that r is L sine alpha. We substitute that into equation 2, then we get t sine theta is equal to m. Instead of r, we put L sine alpha omega squared. We get that t is m L omega squared. If we substitute that into 1, we get m L omega squared cos theta alpha, minus mg is equal to 0, and we get L cos alpha is equal to g over omega squared. That will allow me to calculate omega with the given parameters at the moment, where L is 10, G is 9.8, and we'll get this will carve out a circle at 1.06 radians per second. Okay, and so if we start it, okay, we can see that the radius doesn't actually have an effect. If I change L though, the smaller it will go faster, and then obviously it will go slower. But if I change R, this has no effect whatsoever, and you can see that very clearly from this app. Okay, just reset that, just do it again. Okay, if I change L, make it very small, it's going to spin faster. You can try this for yourselves. Okay, but if I change R, the rate does not change. Okay, so this Geogebra app will be in the notes of the video. I hope you've understood, and I thank you very much for watching.